Good morning, class. How's everybody doing today? Good, good. How was your spring break? All right. So today we're going to be doing something very interesting. It's one of the most important concepts in mathematics, or specifically in geometry. It's the Pythagorean theorem. Okay? So before we dive into our lesson, I do have a warm-up ready for you guys. Let's go ahead and do that warm-up on your packets. We're Roman numerals number 1. Go ahead and attempt those 6 problems. They should be easy in review for you guys. So I'll give you guys about 3 minutes to complete those. Okay? Let's go ahead and start. Okay, let's go over our warm-up problems. Okay? So we have A, B, C, D, E, and F. Okay, so for number 1, 7 squared. Can somebody raise their hand and answer that for me? Jocelyn? Okay, 7 squared is 49. All right, somebody else. Jocelyn, can you popcorn somebody else for me? Okay, so I figure B is 81. What about C? Okay, so C, B and C, students generally make this common mistakes where if you have, let's say, if you have like B, where you have -9 squared, okay, for most people, if you plug this into the calculator, I see a lot of students make this mistake, so make sure you pay attention. So if you plug this into the calculator, be sure to put the parentheses outside of the -9, okay? So that way the calculator knows that you're doing the -9 first before you square, okay? Otherwise, the calculator will give you -81, which is incorrect, okay? So we take -9 squared, that's 81. All right, can you popcorn somebody else, Joseph? Okay, for C, -6 squared minus 8 squared, -6 squared is 36, minus 64, that gives me -28, right? Okay, easy. All right, if you need help, or if you conflict, let me know. Raise your hand and let me know, okay? All right, for D, root of 9 is 3, okay? So square root of 9 is 3 because 3 squared is 9. Okay, E is root of 36 is 6, plus root of 49 is 7, that gives me 13. And then F is a bit challenging because it combines every concepts of square roots and squares, radical and exponents. So 11 squared, that gives me 121, minus root of 81 is 9, and then -6 squared, that's 36, and then if you add them up all together, that gives you -148. Okay? All right, easy? Are we all on the same page? Good, good. Okay, how are we feeling about exponents and radicals? Thumbs up in front of your chest, thumbs up if you feel confident. This is easy review, kind of on the sideway if you're getting there, and downward if you feel like I forgot all of this. Let's go ahead and vote. Okay, okay. All right, good. Seems like everybody understands and remembers how to do these types of problems. Okay, so the reason why we have this warm-up that deal with radical and exponents is because our lessons today, in essence, the main operations in the Pythagorean theorem is square root and square of a number. That's why I wanted to do that warm-up with you guys to kind of refresh our memories on exponents and radicals, okay? All right, now look at your packets. There should be a scissors on each of your desks. You're gonna partner up with someone next to you or someone you prefer. Make sure there's minimal movement. You're going to cut out 3 squares labeled A, B, C's on your packet. For square B, you're going to cut it into 4 smaller parts along those pre-drawn lines that I have for you guys, okay? All right, and then your job and your partner's job is to fit square A and 4 pieces of square B neatly on 2 square C's. And after you guys done that, try to attempt the 3 questions that follow, okay? So if you're stuck, ask your partner. You guys are working together quietly. There can be talking, but minimal talking. I shouldn't hear you guys from up here, okay? And make sure that you guys keep your workspace clean and neatly. Pick up all your trashes after you cut them out. And I'll give you guys about 5 minutes to complete these and answer those questions. Okay, are we all ready? Any questions? All right, let's start. So this is a student activity, student-centered activity, where they and their partner is going to figure it out, the relationship between square A, B, and C. Okay? All right, time's up. Anybody needs more time? Okay, this is a fairly easy activity, right? Just cut them out and try to fit them all into a square C. All right, were we all able to fit square B's and A's onto a square C perfectly? Does anybody had a issue with fitting them onto square C? Yes? Okay. So let's go ahead and go through these problems. Somebody volunteer and answer bullet number one for me, please. Renata. Okay, since squares A and square B fit perfectly onto square C, we can say that the area of square A and B combined is equal to the area of square C. Good job, Renata. That is correct, because when you fit something or certain objects onto another objects, what you're essentially doing is you're taking the area of the small objects and you fit that onto the bigger area of the bigger objects. Okay? So, good job, Renata. Can you popcorn somebody else to answer bullet number two? Okay, Jocelyn. Okay, Jocelyn, so since you already answered today, can you popcorn somebody else to answer if you haven't spoken? Okay, Rosa. Okay, bullet two. What is the formula used to compute the area of a square? That is the area equal to the side squared. So you take the length of a square and you square that. That means you times itself to give you the area of a square. Everybody remember that? Okay, good. All right, last bullet. Notice that the side of each squared, A, B, C, creates a right triangle in the middle. Using your best knowledge about squares and triangles, what are some observations you can make about figure 1 above? Okay, somebody volunteered. This is a pretty significant question. It ties into our main lesson for today. Anybody? Okay, I'll give you about 10 seconds to discuss with your partner because this is a big question and I want you guys to really, really think about it. Use the experiments that you guys just did and all your knowledge prior to that and try to answer this bullet points for 10 seconds. Okay? Okay, go ahead and start for 10 seconds. Okay, 10 seconds up. Does anybody have an opinion or have a educated guess about this? Okay, Marcus. Okay, so using your best knowledge about squares and triangles, the observations that you made is that the area of square A plus the area of square B is equal to the area of square C. Okay, but how does that relate to the triangle in the middle that is formed by the 3 squares? Somebody want to help mark this out? Okay, Natalie. Okay, so Natalie said that you take the 2 shorter sides of the right triangle and you square them. After you square them, you combine them. That is equivalent to the square of the longer side of the right triangle. That is precisely correct. Okay, everybody clap for Natalie and Marcus. Okay, the experiments or the activity that I just have you guys done is a demonstration or a visualization or an illustration of the Pythagorean theorem. Okay, and it's essentially what you guys just did or what Natalie and Marcus just said. the sum of the squared of the two shorter sides of a right triangle is equal to the square of the longer side of the right triangle. Okay? All right, so let's go to our Roman numerals 3. Okay? Okay, recall, in a right triangle, there are how many types of sides? Anybody? Somebody raise your hand and tell me. Who thinks it's 2? Matter, who thinks it's 1? Who thinks it's 1? Okay, there's one person. Who thinks it's 2 types? Okay, I see some hands up. Who thinks it's 3 types? Okay, a few hands up. All right, thank you for all volunteering. There are actually 2 types of sides, okay? The first types are called legs. There are, in a right triangle, there are 2 legs. They're considered, let's do in bullet 1, they're considered what? They're considered perpendicular. Okay? Because they form a right angle. Those 2 shorter sides or shorter legs, they form a right triangle. They form a right angle. So they're perpendicular to each other, okay? From now on, when we're dealing with right triangle or right angle or 2 lines forming a right angle, I want you guys to use this term, okay? Perpendicular, when the 2 lines form a 90 degrees angle, okay? All right, the 2 legs may or may not be equal to each other. Sometimes, or most of the times, they're usually of different length, okay? But you are going to see certain cases where they have the same length, okay? All right, and the longest side, okay, let me draw the right triangle out. And when we're dealing with right triangle, make sure that you draw this kind of little square to denote that it's a right triangle, okay? And if you ever presented with, or if you ever given a seemingly right triangle, but there's no indication that it's a right triangle, do not assume so. Okay, that's also a common misconception that students usually make mistakes on my tests. Okay, all right. So we call this is the legs because it's short and it forms a right angle. Oh, there's no S. What am I doing? Okay, and the longer side, we call it the hypotenuse. Okay, and it's usually opposite from our right angle. Okay. And we usually denote mathematicians, or for the sake of our benefits, we usually denote the 2 sides A and B, and the hypotenuse is C. Okay? So we just call it size A, size B, and size C to kind of ease up our process. Okay, so now I've give you all of the vocabs and the backup kind of ideas about our Pythagorean theorem. Let's dive into our formal definition of the Pythagorean theorem. Okay? Okay, somebody read the Pythagorean theorem in our highlighted box for me, please. Matthew? The Pythagorean theorem in a right triangle, the Pythagorean theorem says, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. Okay? This theorem can be represented algebraically as a squared plus b squares equals to c squared. Okay? So, let's go ahead and prove that. So, proof. Okay, look on your packets and see. So, I started with a right triangle of A, B, and C, okay? And in order to prove this, I'm going to draw a figure like figure 3 on your sheet, on your packets, okay? So suppose that we have a square as drawn in figure 3, where it is made of a 4 blue right triangle, which is our triangle, and in the middle there's 1 yellow square, okay? So now, let's do our proof. So suppose Okay, make sure you write this down. It's a form of proof. Okay, suppose that we have a square drawn in figure 3, where it's made up of 4 blue right triangles and 1 yellow squares. Okay, and we do see that if I were to find an area of this square, what would my formula be? Or how would I compute it? Somebody volunteer and tell me. Somebody? Okay, David? Yes, so since the side of the square is a plus b, so in order to find the area, we just square that, or we take a plus b times a plus b. That's our area for the square, for the big squares. Okay? Now we're going to compute the areas of the smaller shapes. Let's compute the area of the yellow square. So the area of the yellow square, I denote it as ys, yellow square. That's just, so the side length of the square is c. So the area is just c squared. Yes? Okay? Alright, if you feel like I'm going too fast, just raise your hand and let me know that I'm going too fast and I'll slow it down a little bit. Okay? Alright. And then the area of one triangle, one right triangle, is what? A times b over 2, right? And since we have 4 right triangle, we're going to multiply that by 4. And that simplifies into 2ab. Okay? Alright, and now we're going to add up the areas of all the small shapes. So our big A is going to be the c squared from the yellow square, the area of the yellow square, and plus 2ab from the area of 4 right triangles. So this is our area of all the smaller shapes, c squared plus 2ab. Okay? So now let's set them up equal to each other, because they are equal, right? They're essentially one shapes. Okay? So we have, let's expand this out. Let's fold it in. So we have a squared plus 2ab plus b squared is equal to c squared plus 2ab. Okay? And now we see there's 2ab on each side. Go ahead and drop that. So we minus 2ab on both sides, and we end up with a squared plus b squared equal to c squared. Okay, does everybody follow? Is there any particular steps that you want me to further explain or re-explain? Okay, we're on the same page. Okay, so here we already proved our Pythagorean theorem. This is exactly our Pythagorean theorem. A squared plus b squared equal to c squares. The sum of the squares of the two shorter sides is equal to the square of the longer size. Yes? Do we all see the lights? Yes, easy, right? It's not as hard as it looks, especially when we do these kind of proof. Okay? And the Pythagorean theorem is one of the few theorems where the converse is also true. You don't see this often in mathematics where a converse of a theorem or of a corollary is true. But in this case of our Pythagorean theorem, we do have it to be true. So the converse is, if there is a square, if you take the square of the length of the longest side, and that is equal to the sum of the squares of the two other sides, then that is a triangle. So in short, so if I have a right triangle, no, matter of fact, if I have a triangle, okay, and if let's call this A, and let's call it B, and this C. If I take A squared plus B squared, and I test that, and if it's equal to C squared, then I know that this is a right triangle. Okay? That's basically what the converse of the Pythagorean theorem tells you. Okay? Alright, let's look at the next page. So the next page, I included some mathematical history. The Pythagorean theorem is among the earliest, one of the earliest theorems to be discovered. It is also one of the most important theorems in mathematics where it is widely used, especially with engineers and architectures. They use that more than often for building and constructing and calculating and things like that. And there is more than one way to do to prove the Pythagorean theorem. I'll let you read that on your own, okay? Let's do some practice. Let's go number 1. So find the missing side of each triangle, rounding answers to the nearest tenth if needed. Okay, I'll give you guys about 1 minute to do problem 1 and 1 minute to do problem 2. Okay? Alright, so for number 1, since our hypotenuse is 13, so we're going to take 13 squared. So we're going to set it up as 12 squared plus x squared equals to 13 squares. Okay? And then so we know that 12 squared is 144 plus x squared equal to 169. So our x squared is equal to 25 and x equal to plus or minus 5. Now, but my final answer has to be x equal to 5. Why did I drop the negative without any reasoning? Anybody have an idea? Yes, because we're dealing with shapes, right? So the length of a shape cannot be negative, so it always has to be positive. Okay, that's kind of like a common sense. All right, let's do problem. Let's go to our word problem. Somebody read number 5 for me, please. Okay, thank you. All right, with a partner, you guys gonna do this problem together. Okay, I'll give you guys about 2 minutes to complete this problem. If you need help, ask your neighbor. If you and your neighbor needs help, you guys can raise your hand and I'll come and help. Okay? All right. I'll give you guys about 3 minutes to complete this problem. Okay. All right, let's go ahead and do that. So, whenever you deal with word problem, it's always recommended that you draw it out as possible. It will make things much easier, okay? So we know that our right triangle, what we're looking for is C, and the porch is 3 feet off the ground, so 3 feet, and it was placed 12 feet away. Okay, and we need to find how long the ramp needs to be. So this is our C. So we know that C squared is going to be 3 squared plus 12 squared. Okay, can somebody go ahead and walk me through the steps? Okay, so I have C squared equal to what? 9 plus 144. That's equal to 153, right? How did you get 153? Where did this come from? And why are we squaring these? Somebody answers? Yes, Davian? Yes, because this is a right triangle, right? According to the word problem. And this is our hypotenuse, so if we square our hypotenuse, that's going to be equal to the sum of the squares of each of our shorter legs. Okay? Thank you for your substantiation. So we know now we take the square root of C squared, and we also take the square root of 153. So our C comes out to about what? What was yours? What were you guys' calculation? Yes, about 12.369 feet. Okay. How do you know this answer is reasonable? Or how can you justify this? Anybody? Tommy? Yes. So if you look at this, we know that the hypotenuse is always going to be our longest side, right? And since this seemingly is the longer of the two sides, is 12 feet, so our hypotenuse should be larger than 12 feet, but not a lot larger. So our answer is reasonably correct, okay? All right, time is about to be up, so the rest of the problems that we haven't gone over in class is to be for homework. And as you guys walk out of my class today, I want you guys to think about this. Can the Pythagorean theorem be used in every types of triangles, not necessarily the right triangle. Can it be used in all types of right triangles? Okay? I want you guys to go home and think about that, and we'll address that, we'll discuss that in our next class. Okay? All right, thank you for today, guys. See you guys tomorrow. Stay safe.